Right, today we're going to be talking about more key features of graphs, increasing, decreasing, extrema, but also end behavior of the graph. So these are things that we're going to be discussing. So domain and range you've done before. So we're going to do those first, just as a quick review. So with domain, it's all the x values. So with the domain, this one is negative infinity to positive infinity. The range is also negative infinity to positive infinity, right? Because the x values and the y values both go to infinity. So then we're going to discuss what an extrema point is. So any extrema point, that just means an extrema point is a place or a point. Oh dear Lord. A place that the graph, there we go, is neither increasing or decreasing. My stylus is acting weird, so that should say increasing or decreasing. Okay, so it's a spot where, if you were driving a car, so say you're driving a car up here, when you get to the top of the hill, you're not going up or down. So that's an extrema point. Now, if I'm going down the hill, I get to this valley right here, I'm neither going up nor down. So those two are considered extrema points. So this point right here is a max extrema. So the max would be at 1, 3. And the min would be here. The min extrema is at 3, -1. So extrema are points where it's neither increasing or decreasing. So to determine values, so that was this one. So to determine the intervals where the graph increases and where the graph decreases, wow, that should say decreases, just deal with that. You are going to do everything but those extrema points. That's how that's going to work. So when you're doing intervals that the graph increases or decreases, you always, so increase or decrease, we always want the value from the x-axis. This is where we're always going to deal with this, from the x-axis. So increasing is picturing yourself going from left to right, always going this way, and you're driving a car. So when you're driving the car, you're taking the car up. Where are you going? Up. So obviously what I just did was going up, so that interval is increasing. And then the interval from here, from this extrema up, is also a value that I'm increasing. So those two intervals are where the graph increases. So when we're talking increasing, we always take our values from the x-axis. So pretend like the y-axis doesn't exist and just do it. So it goes from negative infinity to that extrema point, so to this max. So since the max x value is 1, it's going to go to there. But at that max, remember, the max is neither increasing or decreasing. So it cannot be included, so we have to use a parenthesis here. And then also another value, or interval that it's increasing, starts at this other extrema point. So the x value for that extrema point is 3, and it goes to infinity. So this is the values where this graph, I'm sorry it's so messy, is increasing. So then where does the graph decrease? Well, it's the rest of it. So from here, from one extrema to the other. So it is, remember, it's always the x value. So this is my x value, and so is this one. So it's from 1 to 3 that this graph is going down. So picture yourself driving a car. Am I driving it down? So then the very last thing that we're going to talk about in this is end behavior. End behavior is what happens when the graph goes on forever. What happens after all these little curlicues have happened? So I have all these little curly, like it goes up and down. It's wonderful. But what happens when it goes really far off to both ends? And that's what we have to ask ourselves. What is happening to the graph when x is going to the two infinities? So end behavior is dealing with the ends of the graph, not the middles. This is really considered part we're looking at is the middles. What happens at the end? Okay, so what happens is we want to ask ourselves two questions. What happens when x is going this way? So when x goes to positive infinity. And what happens when x goes to negative infinity? So end behavior always starts like that, always. So the end behavior, as x goes to infinity, what's happening to the graph? So the graph is f of x. So is the graph going up or is the graph going down? So I'm going this way. What's happening to the graph? Well, this graph, when I'm going this way, this graph is going up. So the graph is going to positive infinity. When I'm going this way, what's happening to the graph? Well, this graph here, it's going down. So we were comparing the two. We're looking at when x is going to negative infinity, what's happening to the graph? Well, in this case, the graph is going down. It's going to negative infinity. Right, so let's look at the next one here. So domain and range, we'll give you a second, you try that. Okay, hopefully you got these two for the domain and the range. The extrema, remember, it's where the graph is neither increasing or decreasing. So any mountain or valley is going to be your extrema. So here are two mountains, here and here. So those are going to be your maxes. Those are, technically those are maxes for the whole problem, but those are the max for the, they're also considered extrema. So it's 0, 2 for one, and 2, 2 for the other. The other value is a min, so at that point in a valley, it's neither increasing or decreasing, so that's 1, 0. Okay, so where is the graph increasing? So all the values, remember, you always are moving from left to right with the increasing or decreasing. You always get your values from the x-axis, so never look at the y-axis when you're getting values here. Okay, you're looking what the graph is doing, but you want to only get your your numbers from the x-axis. So it's increasing it here. So when you're increasing, that would be negative infinity to the to the 0. Remember, we're looking, really you want to look at your extrema points. So these points will all exist in your increasing and decreasing, never the y's. So if you're looking at the point 0, 2, make sure you're taking the 0 and not the 2. Okay, that's an interval there. Is increasing. This interval right here is also increasing. So between the min and the max. So this is the min, this is the max. So it's between 1 and 2. And then that's it. That's the increasing. So decreasing is between this max and this min. It's going down. So 0, 1. Again, these are intervals, so it's hard sometimes to tell the difference between an interval and a point, but these are the intervals. And then from here down, it's going down. So it's 2 to infinity. So those are our decreasing. Finally, we want to do our end behavior. So in the end behavior, you have to think about what's happening to the graph in either direction. So this is the only one where it gets a little weird because you have to deal with what's happening. So finally, the end behavior, remember when you're doing end behavior, it's always two options. X is going to infinity and x is going to negative infinity. You have to see what's happening in these two spots. So when x is going this way, what's happening to the graph? Well, the end behavior is it's going down. And also what's happening when it's going to negative infinity this way, the graph is going down. All right, have a good day.